All right, 3.4. We are now combining transformations. We're going to do more than one thing at a time. So we're going to have some stretching, some reflecting, and some translating all at the same time. All right, page 220 there shows you a little bit about order, what I just was talking about there. So, graph of y equals x cubed. We got it going right there. Perfect. So now, first thing we're going to do, translating 2 units down. If we do that first, and then we take a vertical stretch by a factor of 3, we get that green graph. If we do the other one, where we first of all do the vertical stretch, you get that blue line, and then you do a translation of 2 down. And I don't have that graph, but in your book you can see that it comes to here. Oops, like that. Which is not the same as the first one. So because of that, we're going to have an order. And I just talked about that order. So make sure you write that down. Stretch, reflect, and translate, or reflect, stretch, translate. Either of them will work. All right, example number 1. I'm going to again change this into just a stretch by a factor of 1/3. So we're doing a stretch, vertical stretch, factor 1/3, translation 2 units up. So vertical stretch by factor of 1/3 means multiply all y by 1/3, and translation 2 up means add 2, 2, and it's going up, so to the y values. All right, let's do the stretch part first. So take every point, we're going to multiply it by 2, so that means how far away from the axis it is, from the x-axis, and then move it 2 up. So let's start with this point here. Multiply it by 2, it's right now at 3, multiplied by 1/3, I don't know why I'm saying 2, multiplied by 1/3, so 3 becomes 1, and then move it 2 up. Hey, it went back to the same place. That's kind of cool. So because it's in the same place, does that make it invariant? No. It moved. It just happened to get back to the same place, but it did actually move. And it got back to there. So invariant points, only ones that don't move at all. So now we got -3 multiplied by 1/3 takes us to 1, -1, and move it 2 up. 1, 1, 2. So it's now here. Next point. 0 multiplied by 1/3 keeps it in the same place, but then we move it 2 up. 1, 2. And we're there. And last point. It's at 6, multiplied by 1/3, whips it way down to 2, and then move it 2 up. 1, 2. And we connect all of our points now. So we've got the sketch, but now we want to label its image. Means, what's the equation? We're starting with y equals g of x. So, the vertical stretch by a factor of 1/3 means we are replacing the y with, when we're doing the replacement, we do the opposite. I'm always going to show the replacement method. You can always jump to the answer yourself. Add 2 to the y. So then that's followed by a y translation 2 up. So that means opposite, -2. do them in that order. So we start with y equals g at x. First of all, we put 3y in. And now we put the second one. Wherever we see a y, put y minus 2. You got to put brackets. We got to substitute. So that's where it's sitting. Everything's on the correct side. Now we're going to start taking everything over to the other side to isolate the y. So y minus 2 equals 1/3 g at x. Add the 2 over. Y equals 1/3 g at x plus 2. There's your final answer. And just label that with your graph, which is y equals 1/3 g at x plus 2. Now, of course, you could have said, hey, I can just jump straight there. Don't have to do any opposites. And I'm okay with that. That's fine. Only works with the vertical because they're on the wrong side. All right, bringing it all together from 3.1 to 3.3. Here's your form. We've got the vertical translation. We've got the vertical stretch. We've got horizontal stretch. And we've got horizontal translation. Those letters K, A, B, and H, those are called parameters. The X and the Y are the variables. Those other letters are the parameters. So reviewing it all, we can say, all right, if we are taking that y minus k, hey, we can throw it onto the other side. We could then say, get everything equal to y equals a f b bracket x minus h bracket plus k. You can have it sitting this way. In order to talk about transformations, the trick here, I'm going to star this. This is the trick. And they love trying to trick you on this one on your diploma. You must have this double bracketed. Or in other words, you've got to factor out your stretch factor. So factor out horizontal stretch so that it's double bracketed. You'll see what I mean as we go along. If we bring all this together, we've got our x value, horizontal. First thing is the stretch by a factor of 1 over b. Hey, x over b. Then we go, the next one, we got minus h in there. We're doing the opposite. If it's horizontal like this, all on the right side, we do the opposite of the b, which is multiplied by 1 over b, and then we add the h on the end. There's our x coordinate. The y coordinate, a value, it's on the wrong side, so we can just multiply it by the a. I've got this sitting on the wrong side, just add the k. As long as it's on the wrong side, you don't have to do the opposite. Alrighty. Number 2. What is this telling us to do? First thing, deal with your stretches first. So this is inside the brackets with the x. All of this is horizontal. So we've got a horizontal stretch by a factor of opposite 2. First thing before you even start here, make sure that this is double bracketed. It is. We're good. We can keep going. So that's our first thing. Horizontal stretch by factor of 2. In other words, that means in English, multiply all x by 2. Next thing, we're going to do our translations. And it doesn't matter which translation you do first. I'm just going to do my horizontal because I'm talking about it right now. So horizontal translation, and that's 1 unit opposite direction to the negatives, left. And finally, we've got this y plus 4. Hey, that's on the correct side where it's supposed to be. So this is a vertical translation, 4 units. And because it's where it's supposed to be, we do the opposite. That is down. The vertical translation means subtract 4 from the y value, and the horizontal translation, because it's going left, subtract 1 from x. We got to do it in the order of the stretches before the translations. Okay, here we go. Let's take each point. They give us 1, 2, 3, 4 points to do. Take this first point, and we're going to multiply all the x's by 2. It goes from 1 to 2, and then move it, subtract 1 back to where it was, and subtract 4. 1, 2, 3, 4. And we've got that one right there. Let's do the next point. Same thing. It's at 2. Multiply the x by 2 takes me to 4. Subtract 1 on the x takes me back to 3. Then go down 4. 1, 2, 3, 4. And we're right in the middle between them. Let's talk about our asymptotes. We've got an asymptote, I'll put it in red, that went through there and there. We're going to do the exact same thing. Multiply the vertical asymptote by 2. It's at 0, so it stays there. But now I move it left 1 and down. Well, it's a line. Moving it down just shifts the line down. So all we're getting to do with this one is moving our asymptote 1 to the left. Let's do our horizontal asymptote. The only thing that's going to affect it is our vertical. And we take it down 4. So 1, 2, 3, 4. Instead of being at y equals 0, our asymptote is now at y equals negative 4. It went down 4 as well. So, connecting our dots, we've got right through here. This y-intercept was actually made from the point that was at 0.5, which was multiplied by 2. From 0.5 went to 1, and then 1 left, and 4 down. That's actually how I got it. Then let's take the other points. We got this point right here. Multiplied by 2, it was at negative 1. So now it becomes negative 2. 1 to the left, it's at negative 3, and 4 down. 1, 2, 3, 4. We're going to put it right there. Take the next one. It's at negative 2 and negative 0.5. Multiplied by 2 gets me to 4, negative 4. 1 to the left, and 4 down. 1, 2, 3, 4. And it's right in the middle of those ones. Same thing. Connect our dots, looking at our asymptotes. Now we've got it drawn. And domain and range. The original domain and range was anything except the asymptote. So this is a fancy way of saying, hey, figure out where the asymptotes are. So our original was just the domain was x cannot equal 0. Your range was also y cannot equal 0, but it could have been anything else. So also xer on the end and yer on the end. Now our new one. Where did the asymptote move to? So in our domain, the asymptote on the x, the vertical asymptote, moved to the left 1. So we're going to take our domain to the left 1. X cannot equal -1, XCR. Then our range, we took it down 4. So I'm going to take my range down 4. That's the way that they like to ask asymptote work. All right. Y equals the square root of x. Graph that. And then what's the domain and range? Ooh, they're being tricky here. Look carefully. What do we notice? It's not double bracketed. Okay, so we got to double bracket that. So first thing, before we can even start any of this work, we've got to take it and factor out. Double bracketed. The square root itself really is like a fancy set of brackets. Factor out that 3, leaves me with x plus 1. Now it's double bracketed. Now I can talk about transformations. Up to that point, we don't start touching transformations until I've got a double bracket. Okay, so stretches first. So first thing, the 3. So we've got a horizontal stretch by a factor of 1/3, the opposite. I don't have any vertical stretch, but I do have a reflection now. So I've got a reflection. Keep everything color coordinated for you. And that's a reflection about it's not in the brackets with the x, so it is a vertical, it is talking about the y, and it's always the opposite axis, reflection about x-axis. Next thing, doesn't matter which translation we do, I'm just going to do horizontal first, or sorry, vertical first, because I see it there first. So we've got a vertical translation, and that's 2 units. And direction, it's either up or down. It's where it's supposed to be, so it is going opposite up. And final one, at +1. This is the one that people are going to get wrong if they don't double bracket. Horizontal translation, and that's 1 unit. It's where it's supposed to be, so opposite to the left. Take it into English for yourself. The first one says multiply x by 1/3. The second one says multiply y by -1. The third one says add 2 to the y. And the fourth one says subtract 1 from x. Take every point and do that. Okay, so let's take the point 0 and 0, multiply the x by 1/3, still 0 and 0, multiply the y by -1, still 0, 0, and 2 up, 1 left. So 2 up, 1 left. Plop it right there. Let's take another point. Let's try this point. It's 4 and 2. Multiply. Oh, yeah, that'll work. So, multiply the x by 1/3. Well, that gives me 1.3. And then, oh, I gotta go back here. I forgot to do the reflection. So let's read. Oh no, that one was okay. Sorry. That one was fine. It's this one I gotta do the reflection on. So it goes to 1/3. Then flip it over the x-axis, whips it down to here, and then 2 up, and 1 left. Right there. Okay, so doing that point again here, so the 4, there we get multiplied by 1/3 on the x takes us to like 1.3. Then we go multiply by -1. So that means it's going to flip all the way down to here. And then we're going up to 1, 2. We're on the x-axis. And 1 to the right puts us at 0.3. So 1/3, just a bit off of there. And now we've got the other easy point, the 9, 3. So 9, 3 is the point we're going to look at now. And we are going, 9, 3. And we're going to take it and multiply by 1/3. Takes us to 3, 3 after the first one. And then multiplying the y by -1, 3, -3. Then we add 2, so we're going to take it 2 up from there. 3, -1. And then moving it 1 to the left, which gives us 2, -1. So 1, 2, and -1 right here. And we get it looking like that. Original domain was x is greater than or equal to 0, y is greater than or equal to 0. Now, we've got our new point that we start at right down over there. Oops, I just noticed a mistake here. That shouldn't have been drawn there. Sorry, that should have been drawn like that. That's where our original point, this original point went to there. Sorry. So we are starting from our domain now is everything from this point, which is -1, and to the right. Oops, that should have been a little bit more in there. -1. So for our new domain, we've got x is now greater than or equal to -1. And our range is everything below that point, which was 2. Y is less than or equal to 2. All right, tricky one now here. We're going from the red to the blue. And we need to see what transformations were done. Well, first of all, we need to see what is the relationship between max and mins. That's your easiest place to look at. Let's look at our horizontal stretch first of all. The distance between the two minimums there is 4. So that's 4 in between there. Let's look at the distance between the two new minimums. And that is also 4. So that means there's no horizontal stretch. Let's do the same thing with the vertical. Originally, from the max to the min, there was, so there's 8 on the bottom and 8 on the top. So that means between the two of them originally is 16. On the new one, between the two max and the min, is only 8 now. So we had 16 vertically, now it's 8. That means we must have had a vertical stretch by a factor of 1/2. We're half the height. So let's take a point. I'm going to use point A. If I took point A, half of the distance to the x-axis, that point is 8 above, half of the distance would only be at 4. So we would actually be moving that point down to here after that vertical stretch. Now I've got to get it from that point to where A prime is. That's our translation. I've got to go 4 down, 1, 2, 3, 4, and I've got to go to the left 2, 1, 2. So that means we've got a vertical translation of 4 down, and we've got a horizontal translation of 2 left. And you can go through and you can test the other points. You could do it with B if you would like as well, and you'll get the exact same results. So, vertical stretch, that means Y is replaced with Y, 2y. Vertical translation, y is replaced with y plus 4. Horizontal translation, x is replaced with x plus 2. Throw them into your equation, and you got it done. So we're starting with the f of x. So y equals f of x. First of all, do your stretch. 2y equals f of x. Then substitute with brackets, y plus 4 equals f of x. And then last step, 2 bracket, y plus 4 equals f of x plus 2. And last thing, a lot of times they'll do is just resolve for y. So then, y plus 4 equals 1/2 f of x plus 2. And it's okay to leave it there. You'll see a lot of them with the vertical translation still over there. Or take the 4 over, y equals 1/2 f of x plus 2 minus 4. Really, either of these last two are good to leave it at.